Hello everyone, my name is Mostafa-Astro. I am 29 years old and I have a master's degree in astrophysics. First of all, I would like to thank you for giving me this opportunity. Today, I would like to talk about quadratic equations and why they are much more useful than many students think. When students first see an equation containing x or x squared, they often ask, why do we need this? Will I ever use this in my real life? The answer is absolutely yes. In fact, quadratic equations appear everywhere around us. Whenever you see a curved path, there is a good chance that a quadratic equation is involved. For example, the motion of a thrown ball follows a quadratic equation. Engineers, scientists, economists, and many other professionals use quadratic equations regularly. So these equations are much more practical than they may seem at first. Look at the standard form of quadratic equations. It contains of a dot x squared plus b dot x plus c equals 0. Actually, sometimes quadratic equations may look more complicated, but after simplifying them, we can usually rewrite them in this standard form. There are several ways to solve quadratic equations. One of the most elegant and mathematical is using the discriminant, which we call delta method. Delta is equal b squared minus 4a c. The value of delta tells us how many real solutions the equation has. If the delta greater than 0, we have two solutions for equation. And if the delta equals 0, we have only one solution for our equation. And if the delta less than 0, there is no real solution for our equation. At the higher level of mathematics, we learn that these cases involve complex number and there are imaginary solution for equations too. But for now, we will focus on our real solutions. Once we calculate data, we substitute into the quadratic formula and find the solution of equations. Let's see a simple example from physics. Imagine a ball whose height is described by this equation. We want to know when the ball hits the ground. Since the ball is on the ground when its height is 0, we set the equation equals 0. Now we identify the coefficients. A equals 5, B equals -11, and C equals 2. By using this value, we calculate the delta. Delta becomes 81. Since 81 is positive, we know that the equation has two solutions. Substituting everything into the quadratic formula gives us t equals 0.2 second and t equals 2 seconds. These are the time at which the ball is at ground level. And that's how quadratic equations help us solve real world problems. So the next time you see a quadratic equation, don't be afraid of it. Instead, remember that it is a powerful mathematical tool that help us understand motion, engineering, science, and many situations in everyday life. Thank you very much for your attention.